Good day. Welcome to this video where I will show how this final project is made from scratch to finish. Let's get started. Here are the components and materials used in this project. Soldering iron, soldering lead, cyanoacrylate glue, M4 bolts and nuts, M1 bolts and nuts, Phillip head screwdriver, heat shrinks, 12 volts adapter, USB cable, connecting wires, pre-cut acrylic sheets, power bank, Arduino Uno R3, breadboard, 16 by 2 LCD I2C, 5 volts relay module, HCSR4 ultrasonic sensor, RC522 RFID reader, RFID cards, 12 volts solenoid lock, capacitor, diode, green and red LEDs, passive buzzer, and 330 ohm resistors. Let's get to the assembly. First, let us make the casing for the project. Remove all the coverings for the pre-cut acrylic sheets. Then, assemble the casing. Solder the header pins to the RC522 RFID reader. Use connecting wires to be the ends of the 12-volt adapter and secure it using heat shrinks. Mount the components to the casing using M4 and 1 bolts and nuts and cyanoacrylate glue. Now, let's do the connections. The system is powered by a 5V power bank except for the 12V solenoid lock that has a different power supply through the 12V adapter. The positive terminal of the green LED is connected to a 330 ohm resistor and is connected to the digital pin 2 of the Arduino board, while the other end of the green LED is connected to the common GND line. The same goes for the red LED with the exception of the other end of the 330 ohm resistor that is connected to digital pin 4. The passive buzzer is connected to digital pin 5 from the positive and GND from the GND terminal. The ultrasonic sensor's VCC is connected to the common 5V line. Trig to digital pin 8, Echo to digital pin 3, and GND to the common GND line. The 5V relay module's S terminal is connected to digital pin 7, positive terminal to the common 5V line, negative terminal to GND, and no to the positive of the 12V adapter. The rectifier diode is in a parallel reverse bias connection with its cathode in between the COM of the 5V relay module and the positive of the 12V solenoid lock, and its anode in between the negative of the 12V adapter and the negative of the 12V solenoid lock. Its purpose is to block the kickback voltage from the solenoid lock as it is de-energized, which can cause damage to the components in the circuit, especially sensitive ones like the RFID reader. The LCD module's GND is connected to the common GND line, VCC to the common 5V line, SDA to analog pin 4, and SCL to analog pin 5. The RFID reader has the greatest number of connections, having a total of 7 connections. Its SDA is connected to digital pin 10, SCK connected to digital pin 13, MOSI to digital pin 11, MISO to digital pin 12, GND to common GND line, RST to digital pin 9, and 3.3 to the 3V pin of the Arduino. Finally, the capacitor is connected at the beginning of the common 5V and common GND lines with the purpose of filtering the unwanted frequencies that can damage other components in the circuit, and also serving as a backup power supply for the LCD module in case of low voltage supply from the Arduino microcontroller when switching close to 5V relay that may lead to underdriven display or poor contrast between the background and the characters displayed. Upload the sketch to the Arduino microcontroller and then let us proceed to testing. The RC522 RFID reader continuously reads for RFID cards, tags in which the UID read will be converted into hexadecimal format, and will be compared to the set authorized UID. If the UID of the RFID card tag is similar to the set authorized UID, the green LED will light, and the buzzer will make a sound with a 500 Hz frequency, both for 0.3 seconds, and the lock would automatically open for 10 seconds with the addition of the LCD module displaying access granted, followed by the user-defined function LCD print, which then displays tap your card tag in the LCD module. If the UID of the RFID card tag is not similar to the set authorized UID, the red LED will light. The buzzer will make a sound with a 500 Hz frequency, and the LCD module will display access denied, all for 1 second, followed by the user-defined function LCD print, which then displays tap your card tag in the LCD module. When a person, object is within the 20 cm range, the green LED will light and the buzzer will make a sound with a 500 Hz frequency, both for 0.3 seconds, and the lock would automatically open for 10 seconds. Let us now install the project to see if it works with the door. as we can though the project is a success. That would be all for this video. Thank you for watching.